Hello chemistry students, this is a video to review how to solve mole-to-mole stoichiometry problems. And the very first thing in any stoichiometry problem is you need to look at the equation that you're given and make sure that it's balanced. Just by glancing at this, I can see that my hydrogens aren't balanced and my potassiums are not balanced. So I'm going to go ahead and do that first. So since I've got 3 hydrogens here on my reactant side, I'm going to make 3 hydrogens on my product side by putting a coefficient of 3. And that's going to distribute to my chlorines, which means that my chlorines on my reactant side are imbalanced because I've only got 1 there. So I need to put a 3 there. And in putting that last 3 there, I have successfully balanced my potassiums on the product side. So this equation is now balanced. Now that it's balanced, we can take a look at our question and see if we can't solve this. If I begin with 8.25 moles of potassium chloride, how many moles of potassium phosphate will I produce? Well, as with any kind of question using dimensional analysis, we're always going to start with what we're given. And in this problem, we're given 8.25 moles of potassium chloride. So I'm going to write that here. And I know that in the past you haven't had to write the compounds formula, but I'm going to have you go ahead and do that because once the problems get longer, you may get confused. So with any dimensional analysis, once we write down our given and we draw our grid, I'm going to demote the unit. But I'm going to demote moles of KCl, pretending that that's all the same unit. And then at the top, I'm going to put what I'm looking for. Well, I want to know how many moles of potassium phosphate I'm looking for. That's what I want from the problem. So I'm going to write moles of potassium phosphate on top. Now all we have to do is figure out what numbers to put here and here. What I'm going to use is something called the mole ratio, which I believe everybody has practiced already in class. All that we do is we plug in the coefficients that are in front of each compound in the equation. So in front of potassium chloride, I have a 3, so I'm going to put a 3 here. And in front of potassium phosphate, I have no number. So I'm just going to assume that that's 1. Okay, we're ready to calculate. I know that I stop here because I have what I want at the top of my dimensional analysis grid. Moles of potassium chloride are going to go away. They cancel out. And now I'm going to multiply 8.25 times 1, which is 8.25. And on the bottom, I'm going to bring over my 3. And when I divide these out, I get 2.75 moles of potassium phosphate. And this is my final answer. Okay, let's use this equation to solve another problem, but this time what I'm going to do is I'm going to ask you to pause this video so that you can try and work it out on your own. I will tell you the answer, and if you need to have the explanation of the solution, then you can play this video out to the end, and if not, then you can move on to the next one. But my next question is, if I want to produce 0.032 moles of HCl, how much hydrogen phosphate should I start with? So now what we're looking at is HCl, or hydrochloric acid, and we want to know how much hydrogen phosphate we want to start with. So I've just drawn a box around the 2 compounds that we're going to be dealing with just to lessen the confusion. So, all right, I'm going to let you try this on your own. So go ahead and hit pause and go ahead and work the problem. Okay. So if you worked this problem correctly, your answer would be 0.01 moles of hydrogen phosphate. How did you do? There's your answer. All right, so here's the solution to this problem. Even though it sounds like in this problem we're starting with the end because the problem says if I want to produce, meaning my end result, a lot of students are afraid to start by putting 0.032 moles first into the grid. But I just want to encourage you to go ahead and do that. Follow the same steps as you would with any other kind of problem. Because with stoichiometry, you can go forwards or backwards or sideways, and you'll still end up with the same answer. So we're going to go ahead and do that. 0.032 moles of HCl. Demote the unit and put what you're looking for on top. So the numbers that go here and here in the blanks come from the equation itself. So the number or the coefficient that's in front of HCl is the number 3. So I'm going to go ahead and put a 3 there. And in front of hydrogen phosphate, we don't have anything, so we assume that there's a 1. Now what we're going to do is cross out moles of HCl. We have 0.032 times 1, which is 0.032, and we're going to divide that by 3, and the answer indeed is 0.01 moles of H3PO4. And that is the final answer. I hope this video helped you out with your homework. Take care.